Last class, what we were doing was we were trying to write down the program of integration.
Yes, sir.
And the function that we were dealing with was t cube by 3. So this was the function that we were dealing with. So now what we are going to do is I have written the program, but I need to show you how it works. So for that, what we are going to follow is we are going to execute this program and we are going to look at the output of each line one by one. Okay.
Yes, sir.
Okay. So let me execute this program and we are going to look at now only the output of first line. So if I execute, this is the output of first line. So what is the output of first line? 0.1 के increment में 3 तक you are going to see the vector of time instants. Are you with me?
Yes, sir.
So I have discussed this command in length in the last class. So this is not difficult to understand. This transpose is necessary because otherwise it will turn out to be a row matrix. Okay. Now, let us look at the second command. So if I execute this, what is the second command? So it is t dot raised to 3 slash 3. So I said in the last class, you cannot multiply this T matrix with the T matrix because their dimensions will not make that multiplication possible. Are you with me?
Yes, sir.
So therefore यहाँ पे हम कैसे करते हैं? We write it as T dot raised to 3. So what does that mean? Each element of T matrix का cube किया जाएगा and then it will be divided by 3. So for example, if you look at the last element, it is 9 because the last element of T matrix is 3. So 3 cube by 9 is nothing but 3 square, which is equal to 9. Happy?
Yes, sir.
Okay. Now we will have this F printed and we will also look at the command circle shift. Circle shift. So if I do this, I will plot a new matrix with F and F1 as the elements. Are you with me?
Yes, sir.
So output of the third command will be visible here. F is the earlier matrix. F1 is the matrix after circle shifting F. F1 is the matrix after circle shifting F. So let us execute that. So just have a look at what has happened. The first matrix, first column here is F matrix. Second column here is F1 matrix. Are you with me?
Yes, sir.
So if you shift elements of F by one row down, you get F1 matrix. So the last element of F matrix comes as the first element of F1. Happy?
Yes, sir.
And now we have made that F1 first element as 0 in the next command. Are you with me?
Yes, sir.
So if I just space this after the next command, you will see F and F1 appear, but with first element of F1 as 0. Happy?
Yes, sir.
Okay. Why did we do that? Because we wanted to take subtractions of consecutive elements of F1. Are you with me?
Yes, sir.
हाँ, तो इंटीग्रेशन हमें करना था, मैंने करके दिखाया था आपको हाउ डू वी इंटीग्रेट. तो अगर इंटीग्रेशन करना है तो what we can idealize is F2 means you will consider the second element of F matrix, then first element of F matrix. इनका जो average value है, that average value will be prevalent over time 0 to 0.01. Then the average value of 3.33 and 2.66 will be prevalent over time interval 0.01 to 0.02. ऐसे करने वाले. Are you with me?
Yes, sir.
So what I mean to say is this. देखो, we needed to find out integration. Just give me a second. we need to find out integration f of t dt from 0 to 3 seconds, right? Are you with
Yes,
me?
sir. Yes, sir.
What we have done is we have divided this 0 to 3 in the increments of 0 0.01, 0 0.02, like that, up to 3. Are you with me?
Yes, sir.
Then now over this interval, what I will do is I will find out value of f of 0. Then I will find out value of f of 0 0.01, and I will assume this average value is prevalent over 0 to 0 0.01. So I will multiply this by 0 0.01 minus 0. Are you with me?
Yes, sir.
हाँ, so ये ग्राफिकली कैसे रिप्रेजेंट किया जा सकता है, तो जरा देखो. इफ द फंक्शन looks something like this, so what I am going to do here is from 0 to 0.1, so whatever is the value of function here and value of function here, उसका मैं average निकालने वाला हूँ, and I will assume that this average value is constant over this entire 0 to 0.01. Happy?
Yes, sir.
Then what is the next thing that I am going to do? I am going to consider interval 0.02 to 0.01, और उसके ऊपर I am going to idealize value of f of 0.01 and value of f of 0.02 का जो एवरेज है, that average value I am going to idealize it. Are you with me?
Yes, sir.
हाँ, तो इसकी जो एवरेज वैल्यू आएगी, that average value I am going to idealize it to be constant over this integral. So it is equal to f of 0.01 plus f of 0.02, है ना, डिवाइडेड बाय 2.
2.
और ऐसे कब तक चलेगा? So this will go on till f of 2.99 plus f of 3 डिवाइडेड बाय 2. ठीक है, ये वैल्यू मैंने कांस्टेंट यहाँ पे पकड़ ली 0. इट विल बी 3 माइनस 2.99. हैप्पी? आर यू विथ मी?
Yes, sir.
हाँ, तो ये जो सम हमें करनी है, उस सारे सम में what is the value that I need to calculate? I need to calculate f of I, then this is f of I plus 1 divided by 2. ये वैल्यू लगने वाली. Do you agree with me?
Yes, sir.
So let us say this is f of 0. I have the values in this sequence. This is f of 0, then f of 0.01, then I have f of 0.02. तो if you look at the first term, उसमें हमें क्या करना है? इन दोनों की सम लेनी. Do you agree with me?
Yes, sir.
In second, what do we have to do? We have to take sum of these two. In the third, we will have to take the sum of next two. Are you with me?
Yes, sir.
So इन दोनों की जो सम है, I want it here. इन दोनों की सम है, I want it here. Are you with me?
Yes, sir.
हाँ, तो ये करने के लिए मैं क्या कर सकता हूँ? I can just replace this matrix by another matrix जिसमें इसका हर एक एलिमेंट एक रो से डाउन शिफ्ट हुआ है. Are you with me? So I can have next matrix as this, f0, then f of 0.01, and so on and so forth. If I add these two and I will forcefully make the first term as 0. So if I add these two matrices, are you with me? Then
Yes, sir.
I get these terms. Do you agree with me?
Correct, sir.
हाँ, तो वो सारे टर्म्स हम पहले कैलकुलेट कर रहे हैं. सो हाउ डिड वी कैलकुलेट दैट? सो जरा यहाँ पे ध्यान दो. F2 ये हमने मैट्रिक्स डिफाइन किया है. जो F2 matrix is what? It is sum of F plus F1 by 2. Happy?
Yes, sir.
F plus F1 by 2. So now what we will do is we will print the output of F, F1 and F2. Are you with me?
Yes, sir.
So let us print that. So देखो ये दो एलिमेंट्स की सम बाय 2 इज दिस कॉलम. यू कैन क्रॉस वेरीफाई इट हियर. 0.00112 plus 0.00091 by 2 is this. Are you with me?
Yes, sir.
And what is 0.00091? It is the earlier element. So effectively what you are going to do is 0.00091 plus 0.00112 by 2, and that you are going to report it here. Happy?
Yes, sir.
अब ये जो वैल्यूज है, these values are to be multiplied by ti plus 1, sorry, ti minus ti minus 1. देखो,
Correct, sir.
this value is for time 0, this value is for time 0.01, this value is for time 0.02. So what you need to do is 0.01 minus 0 से इस सम को मल्टीप्लाई करना है. Do you agree with me?
Yes, sir.
So how do we do that? So we do similar strategy for t. अब हमने t1 लिया, t1 को सर्कल शिफ्ट किया. Are you with me? So by one row all elements of t have been moved down. Are you with me?
Yes, sir.
And then forcefully I make first element of t1 as 0, and then I say t2 is equal to t minus t1. Are you with me? यहाँ पे
Yes,
जैसे
sir.
हमने f प्लस f1 बाय 2 किया है, वैसे यहाँ पे क्या करना पड़ेगा? यहाँ पे करना पड़ेगा t माइनस t1. Do you get that?
Yes, sir.
Okay. So now let me print the outcome of this t. So t2 f, f1 f2. Just give me a second. Hello.
Yes, sir.
Yeah. So let us plot the output of T2 F, F1, F2. So just have a look at, oh, we need to can delete this. Okay. Now, so just have a look at this. Every interval is 0.01 because we have uniform interval at which we have obtained the values of F. Do you agree with me?
Yes, sir.
So therefore, 0.01 minus 0 will be equal to 0.02 minus 0.01 will be equal to 0.0 minus 0.01. Happy?
Yes, sir.
हाँ ना. So अब जरा मुझे बताओ ये दो जो कॉलम्स है, what do these two columns indicate? Now I will take output of only T2 and F2. T2 और F2 का ही आउटपुट ले लेंगे. Let us try to find. So this is T2, this is F2. What is F2? F2 is F plus F1 by 2. It is the average value, which is going to be constant over this integral T2. समझ में आ रहा है?
Yes, sir.
So I will have to multiply these two. इन दोनों को मुझे multiply करना पड़ेगा. देखो, there is a multiplication here. Agreed?
Sir.
Are you with
Yes.
me?
Yes, sir.
हाँ. There is a multiplication. सो ये मल्टीप्लाई करना पड़ेगा. सो हाउ डू आई डू द मल्टीप्लीकेशन? नेचुरली यू कैनॉट मल्टीप्लाई डायरेक्टली. यहाँ पे F2 इंटू T2 नहीं हो सकता, बिकॉज द साइज ऑफ F2 एंड साइज ऑफ T2 आर इन सच अ फैशन दैट देयर मल्टीप्लीकेशन इज नॉट पॉसिबल. आर यू विथ मी?
Yes, sir.
But every element of F2 has to be multiplied by corresponding element of T2.
T2.
Are you with me?
Yes, sir.
So that's what we need to do. And how do we do that? तो वो मल्टीप्लीकेशन मैंने F3 करके प्लॉट किया. F3 is equal to F2 into T2. Do you agree with me?
Yes, sir.
हाँ, okay. अब जरा यहाँ पे ध्यान दो. See, if I want to find out integration only up to 0.02, तो क्या करना पड़ेगा? I will need to take the sum of only these two. Agreed?
Correct, sir.
If I want to take the integration up to 0.03, तो क्या करना पड़ेगा? I will have to take sum of this and 0.03. Happy?
Yes, sir.
If I have to find out the integration up to 3, तो क्या करना पड़ेगा? इन सब का सम लेना पड़ेगा.
Correct, sir.
हाँ. So that's what we are trying to do now. ये देखो यहाँ पे क्या कर रहे हैं हम लोग. I want to find out this integration at every value given in T matrix. तो मुझे 0 पे भी इसका इंटीग्रेशन चाहिए, 0.01 पे भी चाहिए, 0.02 पे भी चाहिए, 0.03 पे भी चाहिए. Are you with me? ऐसे सब जगह पे चाहिए. So I have value of T as 0, 0.01, 0.02, 0.03, so on and so forth up to 3. Do you agree with me?
Yes, sir.
हाँ. तो इस हर एक जगह पे I want the integration f of t dt from 0 to that value of t. Are you with me?
Yes, sir.
हाँ, तो कैसे करना पड़ेगा मुझे बताओ. So if I want the integration of this quantity here, I will have to take sum of first two rows. Do you agree with me?
Yes, sir.
तो ये हमने तीसरा ये जो मल्टीप्लीकेशन किए है, इसके पहले दो एलिमेंट है उनका सम लिया, तो मुझे यहाँ पे इंटीग्रेशन अप टू 0.01 मिलेगा. हाँ, 0.02 तक चाहिए तो क्या करना पड़ेगा? आई विल हैव टू टेक सम ऑफ दिस एलिमेंट एंड दिस एलिमेंट ऑफ दिस F2. हैप्पी?
Yes, sir.
हाँ, तो वो करने के लिए आप प्रोग्राम कैसे लिखा है देखो. दैट इज द क्रक्स ऑफ दिस इंटीग्रेशन. हाँ, तो यहाँ पे देखो m इज इक्वल टू लेंथ ऑफ F3. तो F3 में जितने, सो वी हैव नाउ ए ग्राफ ऑफ, वी हैव नाउ T एंड F3 हियर. आर यू विथ मी?
Yes, sir.
0, 0.01, 0.02 ऐसे अप टू 3 तक है, और ये सारे एलिमेंट्स हमारे पास हैं. आर यू विथ मी?
Yes, sir.
हाँ, तो मैंने क्या लिया है देखो, F3 का लेंथ लिया है. सो व्हाट इज द लेंथ ऑफ F3? इट इज नथिंग बट नंबर ऑफ रोज इन F3. डू यू एग्री विथ मी?
Yes, sir.
Those number of rows in F3 are exactly equal to number of rows in T as well. Do you agree?
Correct, sir.
हाँ. So अब आगे चलते हैं. So F4 ऐसा एक मैट्रिक्स मैंने डिफाइन किया है. दिस F4 मैट्रिक्स इज द मैट्रिक्स ऑफ इंटीग्रेशन. ये F4 हमारा रिजल्ट है. दैट मीन्स F4 का यहाँ का जो एलिमेंट है, दैट विल गिव मी द इंटीग्रेशन ऑफ f of t dt फ्रॉम 0 to 0. यहाँ तक का जो एलिमेंट है, इट विल गिव मी इंटीग्रेशन ऑफ f of t dt फ्रॉम 0 to 0.1.
0.0.
आर यू विथ मी?
Yes, sir.
इसका ये जो एलिमेंट है, इट विल गिव मी इंटीग्रेशन ऑफ f of t dt फ्रॉम 0 to 0.02. आर यू विथ मी?
Yes, sir.
और ये लास्ट वाला जो एलिमेंट है, इट इज गोइंग टू गिव मी इंटीग्रेशन ऑफ 0 to 3 f of t dt. हैप्पी?
Yes, sir.
हाँ, तो इस F4 का साइज कितना होगा? इट विल ऑल्सो बी एग्जैक्टली इक्वल टू द साइज ऑफ F3. डू यू एग्री विथ मी?
Correct, sir.
हाँ, तो पहले मैं उसको इनिशियलाइज कर देता हूँ. इनिशियलाइज करने का मतलब क्या है कि मैंने डिफाइन किया F4 एज ए मैट्रिक्स ऑफ जीरोस ऑफ साइज इक्वल टू length of F3 comma 1 column. Are you with me?
करेक्ट सर.
हाँ, तो इसका आउटपुट देखते हैं. So just a second, let me delete this, let me execute this. तो देखो F4 0 का मैट्रिक्स आया, उसका साइज क्या है? उसका साइज इज एग्जैक्टली इक्वल टू साइज ऑफ T मैट्रिक्स एंड साइज ऑफ F3 मैट्रिक्स. हैप्पी?
करेक्ट सर.
हाँ, तो ये कर दिया. पहले ये इनिशियलाइज करना पड़ता है क्योंकि इसमें हर एक जो वैल्यू है आई एम गोइंग टू अपडेट इट लेटर, बट उसके लिए पहले इसको डिफाइन करना पड़ेगा कि F4 इज ए मैट्रिक्स ऑफ दिस साइज. आर यू विथ मी?
करेक्ट सर.
हाँ, अब जरा यहाँ पे देखो, फॉर I इज इक्वल टू 2 टू लेंथ ऑफ F3. चलो ये ऐसे क्यों किया वो भी बताता हूँ. व्हाट विल बी द फर्स्ट एलिमेंट ऑफ F4? 0. वी नो दैट. डू यू एग्री विथ मी?
यस सर.
तो पहला एलिमेंट तो 0 है, तो वहां पे चेंज करने की कोई जरूरत नहीं है. तो चेंज कहाँ करना पड़ेगा? फ्रॉम, देखो कहाँ गया वो लूप. हाँ, फॉर आई इज इक्वल टू, आई होप इट इज रीडेबल. फॉर आई इज इक्वल टू 2 टू लेंथ ऑफ F3. मतलब आई कहाँ से कहाँ तक वेरी होगा? इट कैन वेरी फ्रॉम 2 टू लेंथ ऑफ F3. आर यू विथ मी?
यस सर.
हाँ, तो समझो कि I की वैल्यू 100 है. फॉर एन एग्जाम्पल लेट अस टेक द वैल्यू ऑफ I एज 100. तो पहले मैंने 100 ले लिया, तो I अब 100 हो गया. इमेजिन. आर यू विथ मी?
यस सर.
हाँ, तो पहले मैंने क्या डिफाइन किया है? आई हैव डिफाइंड ए टेम्पररी वेरिएबल कॉल्ड एज सम. सम इज इक्वल टू 0. सम को 0 डिफाइन किया है. आर यू विथ मी?
यस सर.
हाँ, तो फॉर एन इलिस्ट्रेशन आई एम गोइंग टू से, परसेंटेज का मतलब है यहाँ का आगे का कुछ कमांड रीड नहीं करेगा वो, इट विल टेक इट एज ए टेक्स्ट. सो आई हमने 100 लिया सपोज. आर यू विथ मी?
करेक्ट सर.
हाँ, सो कैन यू टेल मी व्हाट इज F4 ऑफ 100? F4 ऑफ 100, सॉरी, F4 ऑफ 100 का मतलब क्या है? तो इसमें 100वां एलिमेंट, मतलब इज इट इंटीग्रेशन ऑफ F ऑफ T dt from 0 till T of 100. Do you agree with me?
यस सर.
T of 100 जो भी वैल्यू रहेगा वहां तक का इंटीग्रेशन इज दिस F4 of 100. Do you agree with me?
यस सर.
I hope I am very clear. देखो जब हमने 0.01 लिखा, that is T of 2. Do you agree with me?
यस सर.
Now what is F4 of 2? So वहां पे अगर मैं देखता हूं तो F4 of 2 is nothing but integration of F of T dt, F of T dt from 0 to T of 2. T of 2 is nothing but 0.01. Do you agree with me?
यस सर.
So उसी तरीके से F4 of 100 क्या होगा? तो F4 of 100 will be integration from 0 to T of 100 F of T dt. Happy?
यस सर.
मतलब क्या करना पड़ेगा मुझे? F3 के पहले 100 एलिमेंट्स का सम लेना पड़ेगा. एग्रीड?
यस सर.
तो F3 के पहले 100 एलिमेंट्स का अगर मैं सम ले लेता हूं तो ये इंटीग्रेशन आ जाएगा. हैप्पी?
यस सर.
हाँ, सो ना वो कैसे करने वाला हूं? देखो, तो पहले मैंने सम को 0 डिफाइन किया है. हाँ, एंड देन आई हैव सेड फॉर j इज इक्वल टू 1 टू i. 1 टू i का मतलब क्या है? 1 टू 100 होगा अभी यहाँ पे. आर यू विथ मी? तो j
यस
कैसे
सर.
जाएगा बताओ मुझे. j विल बी फ्रॉम 1 टू 100 इन दिस पर्टिकुलर केस. हैप्पी?
यस सर.
ये मैं परसेंटेज लिख रहा हूँ, मतलब ये टेक्स्ट जैसा ले रहा है. आई एम जस्ट टेकिंग एन एग्जाम्पल. तो 1 टू 100 सम इज इक्वल टू सम ऑफ F3 ऑफ j. तो j 1 टू 100 है ना, तो सबसे पहले j की वैल्यू क्या होगी? सबसे पहले j की वैल्यू होगी 1. आर यू विथ मी?
यस सर.
j विल बी इक्वल टू 1. अच्छा, अब सम क्या हो जाएगा बोलो मुझे. सम विल बी इक्वल टू सम, अभी सम 0 है, प्लस F3 ऑफ 1. दैट मीन्स इस F3 का पहला एलिमेंट आ गया. डू यू एग्री विथ मी?
Yes, sir.
हाँ, तो सम अब कितना हो गया? सम विल बी नाउ इक्वल टू, सो इस स्टेप के बाद व्हाट इज द वैल्यू ऑफ सम? सम विल बी इक्वल टू f3 of 1. Do you agree with me? Are you with me? Hello? Am I audible? Am
Yes,
I
sir.
audible?
Audible.
Okay. So sum will be now equal to f3 of 1. अब इवेंचुअली ये लूप एंड होगा, ये एंड होने के बाद यहाँ पे आता है फॉर आई इक्वल टू 1 to 100 है ना, तो अब आई की नेक्स्ट वैल्यू, जे की नेक्स्ट वैल्यू क्या है? 2 है. डू यू एग्री विथ मी? हेलो?
Yes, sir. Sorry, sir. I'm having network issue.
Okay, now is it okay?
Sir, no, it's still unstable.
Okay, then let me ask Priyan, can you unmute?
Yes, sir.
Yeah, so have you got the program till now?
Yes, sir.
Okay, so now once this end comes, then it will go to first loop first, innermost loop first. So j is equal to 1 तो हो गया, लेकिन 1 से लेके 100 तक लेके जाना है. Are you with me?
Yes, sir.
So now j will be equal to 2. Are you with me?
Yes, sir.
Now so sum जो कि अभी f3 of 1 है, that will be equal to f3 of 1, mean that sum plus f3 of 2 now, because j has become 2. So at the end of this execution, what will be the value of sum? Tell me. Sum will be equal to f3 of 1 plus f3 of 2. Do you agree with me?
Yes, sir.
Great. Now एंड हो गया, अब j की वैल्यू 3 हो गई. सो आई विल राइट डाउन j इज इक्वल टू नाउ 3. हाँ, j इक्वल टू 3 हो गया. सम इज ऑलरेडी f3 of 1 प्लस f3 of 2 अर्लियर. इसमें अब f3 of 3 ऐड हो जाएगा. सो व्हाट विल बी द सम नाउ? सम विल बी इक्वल टू प्लस f3 of 3. डू यू एग्री विथ मी?
Yes, sir.
हाँ, ऐसे कब तक चलने वाला है? जब तक j 100 नहीं होता. आर यू विथ मी?
Yes, sir.
So what at the end of this loop, once j becomes equal to I, that is 100. So at the end of this loop, what will be the sum? Tell me. It will be f3 of 1 plus f3 of ये सारी चीजें ऐसे करते करते कहाँ तक जाएगा? 100 तक.
100.
You agree with me? Plus f3 of 100. Are you with me?
Yes, sir.
तो what is the end result of this inner loop? Inner loop का end result ये है कि you will get f3 sum of first 100 elements or first I elements of f3 matrix. Do you agree with me?
Yes, sir.
So once that is done, you encounter now this will be done for all values of I from 2 to length of f3. सारे के लिए ये हो जाएगा. एंड ये लूप एंड हो जाए, सॉरी ये इनर लूप यहाँ पे एंड हो जाएगा. आई एम सॉरी, इट इज डन ओनली अप टू 100. ये इनर लूप एंड हो गया. नाउ f4 of I, what is the value of I now? Value of I is 100. So
100.
what is the result of this? f4 of 100, right, will be equal to sum. But what is sum? Sum is this quantity. Do you agree with me?
Yes, sir.
हाँ, तो f4 of 100 तो स्टोर हो गया. नाउ नेक्स्ट एंड स्टेटमेंट. सो नेक्स्ट एंड स्टेटमेंट होने के बाद ये सबसे पहले वाला लूप जाएगा. सो नाउ आई विल बिकम 101. आर यू विथ मी?
Yes, sir.
सो आई हैज बिकम 101. तो ये इनर लूप रन होगा. इनर लूप में क्या होगा? सम विल नाउ बिकम इक्वल टू f3 of 1 to f3 of 101. That will be stored here. f4 of 101 will become now sum up to 101 elements of f3. Are you with me?
Yes, sir.
And this loop will occur for all values of I running from 2 to length of F3. So in the process, I am going to get F4 generated, which is the result. Do you agree with me?
Yes, sir.
So now let us find out the value of F4. Let us plot F4. So इसके बाद I'm going to plot a matrix T and F4. So what does this matrix give? T में जो एलिमेंट है उसके करस्पॉन्डिंग सामने जो F4 की वैल्यू है वो f of t का इंटीग्रेशन उस t तक का है, 0 से लेके. Are you with me?
Yes, sir.
What I mean is will be clear in a while. यहाँ पे रन कर दिया मैंने. ओके. तो सम कहा तो भी मैंने सेमीकोलन निकाल दिया था. Which matrix? F4. So where have we initialized F4? This semicolon needs to be there. Now let me execute. So जरा यहाँ पे ध्यान दो. If I tell you at 0.13 the value is value of F4 is 0.00002. तो इसका मतलब क्या है? Integration f of t dt from 0 to 0.13 is 0.0002. Are you with me?
Yes, sir.
And what is the final integration? Tell me final integration 0 to 3 it is 6.75. ये तो हमने पहले ही दिखाया था कि आंसर 6.75 आना चाहिए. Are you with me?
Yes, sir.
Now let us try to look at what happens to this integration if I increase the time step. ये मैं ऐसे ही रख देता हूँ so that you will understand it later. क्या मैं बोल रहा हूँ? Instead of 0.01 में टाइम स्टेप करने के बजाय अगर मैंने 0.1 में किया. Are you with me?
Yes, sir.
So what does that mean? That means that ये एक वैल्यू है एंड देन एट 1 जो वैल्यू है उसका एवरेज वैल्यू आप इस पूरे इसके ऊपर कांस्टेंट पकड़ोगे. Are you with me?
Yes, sir.
So as you increase the time state, the integration becomes approximate. Error increases. Do you agree with me?
Yes, sir.
So let us try to see what happens to the error if I do this. तो ये execute किया. So see 6.75 exact value था, वो 6.7575 आ गया. So there is some error. Are you with me?
Yes, sir.
Now let us further increase this. So instead of 0.1, let me take it as 0.5. Let us see what happens. It became 6.93. Are you with me?
Yes, sir.
Let me make this as 1. So step size अगर मैंने 1 ले लिया, so it has become 7.5. So as I go on increasing the step size, the integration becomes more and more approximate. Agreed?
Yes, sir.
So accuracy of your integration will always depend upon the step size. So let me take it as 0.001. This will be the most accurate because earlier we had taken the step size as 0.01. Happy?
Yes, sir.
But now this matrix has become so large that this free version of software doesn't allow us to solve it. So we can take it as 0.001 instead of 0.01. Let us see what happens. Still it doesn't allow. So 0.01. 0.01 तक उसने अलाउ किया. इससे अगर हमें कम करना है तो we can go for 0.005. Let us do that. Now it has calculated. So the accuracy is better now, 75002. Are you with me?
Yes, sir.
Okay. So have you understood the program for integration?
Yes, sir.
Okay. Now in today's class, what we will do is we will extend to calculate the response of a single degree of freedom system to arbitrary excitation. Are you with me?
Yes, sir.
So let us try to expand this program. और हम कौन सा प्रॉब्लम सॉल्व करने वाले हैं? सो वी आर गोइंग टू सॉल्व द रिस्पॉन्स ऑफ सिंगल डिग्री ऑफ फ्रीडम सिस्टम. हमारा ये एग्जांपल ले लेते हैं. वी विल हैव मास m. Let us say this is in such a fashion that eta is equal to 0.05. Are you with me?
Yes, sir.
K is equal to 10,000 Newton per meter. M is equal to 100 kg. ये वैल्यूज दे देते हैं. And we want to find out response of a system subjected to sudden loading. Are you with me?
Yes, sir.
So f of t, let me say it is 10 times or 10 nahi, we will take it as 0.1 time, 0.1 times u of क्या कैसे लिखते थे हम? t minus 0. u of t. तो ये कैसे दिखेगा बताओ मुझे? ऐसे दिखेगा. This is f of t. Do you agree with me?
Yes, sir.
Okay. Just a second. Okay. F of t and इसका रिस्पॉन्स हमें चाहिए फ्रॉम 0 to 10 seconds. Are you with me?
Yes, sir.
So this is 10 seconds. This load continues to be there forever. So what is the response of this system? Have we obtained the response? इसका response हमने obtain किया है already. Yes, but now we are going to obtain it using the integration. Are you with me?
Yes, sir.
Imagine that this system is subjected to unit impulse. यूनिट इम्पल्स को अगर सब्जेक्ट किया जाए, or in other words, let me say that at time instant tau, if we consider small time d tau, are you with me?
Yes, sir.
Then what is the impulse that prevails on this small time? So it is f of tau d tau. Do you agree with me?
Yes, sir.
This is the impulse that this mass is subjected to at time instant tau. Then what is the, where do we want to find out the response? We want to find out the response at time t. Are you with me?
Yes, sir.
Okay. Now, how do I model this impulse f of tau d tau? So it is something, this is f of tau is 0.1. So it is 0.1 times d tau. Do you agree with me?
Yes, sir.
So at time tau, the system is subjected to impulse 0.1 d tau. Agreed?
Yes, sir.
Now, do we have response of a system to a unit impulse at time tau? Time tau पे अगर unit impulse है, that means if this system is subjected to chronicle delta tau, इसको अगर ये subject होता तो इसका response क्या रहेगा बताओ मुझे. The response of the system ut will be 1 upon m omega d sin omega dt e raised to minus eta omega t. Are you with me?
Yes, sir.
This is impulse response function. Do you agree with me?
Yes, sir.
और यहाँ पे मुझे क्या लिखना पड़ेगा, t के जगह I will have to write it as t minus tau and sine of omega d t minus tau. Are you with me?
Yes, sir.
T minus tau. I hope you know that this is impulse response function. When the impulse is at when impulse is applied at time instant tau. Happy?
Yes, sir.
तो ये लिख ली, u of am I right? Yes, u of this is the response. Now, how do I find out response due to this train of impulses? तो ये सारे train of impulses है कि नहीं, tau 0 से लेके t तक change हो सकता है. So what I will have to if I have to find out the response due to this function, what I will have to do is u of t, I will have to integrate it from 0 to t e raised to minus eta omega t minus tau divided by m omega d sine of omega d t minus tau. Happy?
Yes, sir.
D tau into 0.1. अच्छा, ये 0.1 into d tau से मल्टीप्लाई क्यों किया? बिकॉज इफ यूनिट इम्पल्स गिव्स यू दिस रिस्पॉन्स, सो 0.1 d tau, ये इम्पल्स का रिस्पॉन्स क्या होगा? सो ड्यू टू 0.1 d tau the response will be this unit impulse के वजह से आने वाला response multiplied by 0.1 d tau. Do you agree with me?
Yes, sir.
So what is u of t? U of t is finally this function. So I have to find out this integration. Are you with me?
Yes, sir.
Now, mind you, here t is the time up to which you are finding out the response, and tau is the variable that varies from 0 to t. Are you with me?
Yes, sir.
And integration is with reference to d tau. Happy?
Yes, sir.
Okay, great. Having said that, now let us try to find out how do we find out this integration using MATLAB. तो इसमें सबसे पहले तो हमें ईटा पता है. Do you know the value of omega? Square root of
K by
k
M.
by m. So k by m is
100.
so this
10.
turns out to be 10. So we know omega is equal to 10 radian per second. What is the value of omega d? It is 10 into square root of 1 minus 0.05 square. Can you tell me how much is that?
Yes, sir.
9.98. Is that right?
Yes, sir.
Okay. So 9.98 is omega d. Now, what do we do next? So we need to find out this integration that I will write u of t is equal to integration 0 to tau 0 to t 0.1 into 0.1 upon m omega d. What is the value of m? 100. What is the value of omega d? 9.98. Happy?
Yes, sir.
m omega d. हाँ, आगे चलो, बोलो. e raised to minus eta omega, so minus 10 minus eta is 0.05 into 10 into t minus tau. Are you with me?
Yes, sir.
T is constant here. because integration is with reference to tau. Happy?
Yes, sir.
This multiplied by sine omega d t minus tau. Happy?
Yes, sir.
This entire thing multiplied by d tau. तो अब जरा देखो, ये जो प्रोग्राम हमने लिया उसमें हमने इंटीग्रेशन किसका किया था? एफ ऑफ टी का किया था ना प्रियन?
Yes, sir.
Here we integrated f of t, right?
Yes, sir.
Here we are integrating what? We are integrating f of tau.
Of tau.
Happy?
Yes, sir.
So here integration is with reference to f of tau. So what is f of tau here? So f of tau is this function. Agreed?
Yes, sir.
And what is 0 to t? So 10 second तक हर टाइम को हमें रिस्पॉन्स चाहिए. So we will first define t. तो देखो यहाँ पे पहले t डिफाइन करते हैं. t I am defining in the increments of 0.5. Let us say कहाँ तक डिफाइन, और let us say 0.05 के इंक्रीमेंट्स में कहाँ तक डिफाइन किया? 10 तक. Happy?
Yes, sir.
So what is the output of this line? Let us execute this. So you are going to get different time intervals. Happy? We
Yes,
can
sir.
even minimize this by taking it as 0.025. That is fine. Are you with me?
Yes, sir.
Okay. Now, what is f of tau now? Instead of t, I will now define f of tau. Are you with me?
Yes, sir.
T becomes now, means each member here becomes now the integration. Happy?
Yes, sir.
It becomes the upper limit of the integration. So when t is equal to 0.025, that means you have to integrate f of tau from 0 to 0.025. Happy?
Yes, sir.
Okay. So for example, in this particular case, uh, let us take t is equal to 0.025. Are you with me? फर्स्ट एलिमेंट.
Yes.
तो इसको हमें क्या करना है? इसका इंटीग्रेशन करना है. कहां से कहां तक करना है? जीरो से एफ ऑफ टाउ का इंटीग्रेशन करना है 0 से 0.025 तक. आर यू विद मी?
Yes, sir.
ओके. सो यहाँ पे ही पहला लूप चालू हो जाएगा. सो फॉर आई इज इक्वल टू 1 to length of t. t ऐसे में करूंगा. आर यू विद मी?
Yes, sir.
When I, let us consider I is equal to 2. तो I is equal to 2 मतलब क्या हुआ बोलो?
Length is 2.
So length is 2, and anyway the first one is 0, so first element is going to be 0, so I will start it from I equal to 2 to length of t. So when I is equal to 2, that means at that time what is the value of t? Value of t, that is t of 2 is equal to 0.025. Do you agree with me?
Yes, sir.
अब मुझे क्या करना है? मुझे इंटीग्रेशन करना है. किसका इंटीग्रेशन करना है? आई नीड टू इंटीग्रेट एफ ऑफ टाउ. कहां से कहां तक? 0 से लेके 0.025 तक. डू यू एग्री विद मी?
Yes, sir.
सो 0 से लेके 0.025 तक अगर मुझे एफ ऑफ टाउ इंटीग्रेट करना है, डू विद मी?
Yes, sir.
So in that case, I will have to define new variable, that is tau. कहां से कहां तक? 0 से लेके
0.025.
0.025 तक. Are you with me?
Yes, sir.
मतलब कहाँ तक? Can I call this as T of I? T of 2 है ना? So T of I. Are you with me?
Yes, sir.
And I will at least require 10 points till this. Are you with me?
Yes, sir.
Or let us take 100 points till this. यहाँ तक मुझे 100 points चाहिए, समझो. So what will I do? I want 100 points. So increment कितना होना चाहिए? कम से कम 100 points चाहिए. So T of I minus 0 और इसको मैंने डिवाइड कर दिया 100 से. Are you with me?
Yes, sir.
Okay. हाँ, तो इस इंटरवल में T of I तक जाना है. So let us do one thing. Let me not start this loop. Instead of that, let me say I is equal to 2 and let us try to plot the value of tau. Are you with me?
Yes, sir.
So let us see what do you get. So you will understand what I am trying to do. Of course, I forgot to give this. देखो tau की वैल्यू 0 से स्टार्ट हुई और व्हाट इज द लास्ट वैल्यू 0.025. 0.025 is the second value of t. Do you agree with me?
Yes, sir.
So ये कर दिया. Have you understood what I am trying to do?
Yes, sir.
हाँ, तो ये टाउ के वैल्यूज आ गए. नाउ आई हैव टू इंटीग्रेट विथ रेफरेंस टू टाउ. ये कर दूंगा. I will again reactivate this. Right now I is 2. That means we are integrating f of tau from 0 to 0.025. उसमें हमने ये टाउ डिफाइन कर दिया. Are you with me?
Yes, sir.
अब मुझे इंटीग्रेशन करना है तो मुझे पहले f of tau तो लगेगा. So I am going to call it as f. What is the value of f of tau? Tell me. F of tau is this. So
Yes.
can I write this value? 0.1 multiplied by 0.1 divided by in bracket 100
Into 9.98.
0.98 bracket complete. This entire thing multiplied by e raised to क्या लिखूं?
0.
Minus
minus 0.05
0.05
into 10 into
into 10
t
into
minus
t minus tau. What is the value of t now here? Value of t is t of I. T of I. Are you with me?
Yes, sir.
And what is the value of tau? Tau of bolo. Tau is the matrix, so tau will remain as it is. Are you with me?
Yes, sir.
लेकिन जो कि ये ऑपरेशन हम ऐसे लिखना पड़ेगा. Each element of tau. So from this I have to subtract, means I have to subtract each element of tau, and corresponding to that I have to multiply this. I hope I have completed the bracket. Yes, I have. This multiplied by sine of bolo. What is omega d? Omega d is 9.98 into t of I minus tau. Agreed?
Yes, sir.
So let us try to now plot. Plot क्या करेंगे? तो plot ये करेंगे. एक मिनट. I will plot the value of tau and f. Are you with me?
Yes, sir.
Again, let us do it for I equal to 2. so there is syntax error. I thought so. So it is going to be 0.1. so यहाँ पे डॉट होना चाहिए, ना कि यहाँ पे, और यहाँ पे डॉट होना चाहिए, ना कि यहाँ पे. अब होगा. what does it say? For x raised to a must be, so okay. So just give me, यहाँ पे होना चाहिए. Yep. So अच्छा, tau and f क्यों नहीं प्लस हुआ? Okay, ये एक सेमीकोलन रहेगा. So now you will see tau and f. Are you able to see that? So f of tau has been calculated for each value of tau up to tau equal to 0.025. Do you agree with me?
Yes, sir.
अब क्या करना है? अब करना है हमें इंटीग्रेशन f of tau का. कहां से कहां तक? f of tau का इंटीग्रेशन needs to be done from 0 to 0.025.
0 to 5.
Are you with me?
Yes, sir.
So do we have program for that? Yes, this is the program we have written that. इसको सिर्फ modify करना पड़ेगा. Are you with me?
Yes, sir.
चलो तो इस प्रोग्राम को modify करते हैं. So what is f1? So I am modifying it. f1 is equal to circ shift. लेकिन अब circ shift क्या करना है? f ही करना है. So f to 1. Do you agree with me?
Yes, sir.
Then you are going to make f1 of 0 forcefully 0. This is as it is. Are you with me?
Yes, sir.
What is f2? f2 is f plus f1 by 2. इसमें कोई चेंज नहीं है. Do you agree with me?
Yes, sir.
Now t1 के जगह हम इंटीग्रेशन किसके साथ कर रहे हैं? टाउ के साथ. So I am going to call it as tau. Circ shift of tau. Are you with me?
Yes, sir.
Then t1 of 1 को 0 बोलना है, तो tau 1 of 1 को 0 बोलना है. Forcible. Are you with me?
Yes, sir.
Then instead of t2 equal to t minus t1, I will call tau 2 equal to tau minus tau 1. Happy?
Yes, sir.
Then I am going to say f3 is equal to f2 into tau 2. Are you with me?
Yes, sir.
Then m is equal to length of tau. Are you with me?
Yes, sir.
Then I am going to define f4. f4 को डिफाइन किया, zeros of length of f3 comma 1. ये तो वैसे के वैसे रहेगा. हैप्पी?
Yes, sir.
नेक्स्ट फॉर लूप, लेकिन जो कि अब मैंने i का लूप ऑलरेडी चालू किया है. सो आई एम गोइंग टू नाउ कॉल दिस एज j. आर यू विथ मी?
Yes, sir.
सो फॉर i इक्वल टू 2 to length of f3 क्या करना है मुझे? सम इक्वल टू 0, और फॉर k इक्वल टू नाउ 1 to j. आर यू विथ मी?
Yes, sir.
अब क्या करना पड़ेगा मुझे? सम इज इक्वल टू सम प्लस f3 ऑफ k. हैप्पी?
Yes, sir.
देन एंड, ये स्टेटमेंट यहाँ पे एंड का आएगा. देन आगे क्या करना है? बोलो. नाउ आई एम नॉट इंटरेस्टेड इन फाइंडिंग आउट दैट सम फॉर ऑल वैल्यूज ऑफ, okay, still I will write it. f4 of j is equal to sum. Are you with me?
Yes, sir.
लेकिन इसमें से मुझे सिर्फ लास्ट वैल्यू में इंटरेस्ट है, बिकॉज आई वांट टू फाइंड आउट दिस इंटीग्रेशन. बीच वाले वैल्यूज में कोई इंटरेस्ट नहीं है. आर यू विथ मी?
Yes, sir.
सो ये करने के बाद I will just type end. So F4 का जो लास्ट वैल्यू है उसमें ही मुझे सिर्फ इंटरेस्ट है इसमें. Are you with me?
Yes, sir.
तो वो वैल्यू मैं कहाँ पे स्टोर करूं? तो ये वैल्यू I will have to store as the result, that is Fy, which is response. Fy of I, T of I की जगह पे स्टोर करना है ना, तो Fy of I is equal to F4 की लास्ट वैल्यू मुझे चाहिए. Are you with me?
Yes, sir.
So that is F4 of length or F4 of M, because M is the length of tau which is equal to length of F4. तो लास्ट वैल्यू. Are you with me?
Yes, sir.
ये कॉमा दे दिया. हाँ, अब मैं कुछ चीजें और करने वाला हूँ. फर्स्ट ऑफ ऑल you will not understand why I have done those things, that I will explain you in the next class, but however let us do that. ये होने के बाद I am going to end the outermost loop. तो चालू कहाँ से किया था? For I equal to तीन आई लूप है, तीन फॉर लूप है इसमें. For I is equal to 2 to length of t, I have done this. Are you with me?
Yes, sir.
And Fy is my result. So first of all, I will have to define Fy. Fy is equal to zeros. क्या साइज है उसका? लेंथ ऑफ t, कॉमा 1. t जितना ही ये मैट्रिक्स है. Are you with me?
Yes, sir.
ये होने के बाद I have started this. At the very beginning, I will have to clear everything. So I will have to clear certain variables. कौन कौन से variables clear करने हैं मुझे? I will have to clear tau. Then I will have to clear f. अच्छा, ये कैसे देते हैं? I think it is okay. I will just go on writing clear f. Then I will have to clear f1. Then I will have to clear f2. Then tau1. I will have to clear tau2. F1, F1, F2 हो गया. tau1, tau2 clear हो गया. F3 also needs to be cleared. F4 also needs to be cleared. M needs to be clear. I hope so. It's done. Now let us try to execute it. So, acha. Okay, let us try to execute it. It will take some time because it has to run 3 loops. And for each loop, it has to take. Okay, so it has gone. Okay, so we will have to increase this time. So let me try with this. And instead of 100, where is that 100? Instead of 100, I will simply say 20. Now let us try. Function demo.m. There is no. Is it executing? Function shadows for library function. Which function are we talking about? Okay, I think it has run now. So now we need to plot. We need to have T and F5. Are you with me?
Yes, sir.
So that's why it was not showing. Let me check. T and so this is the result what we have got. Let us try. Let us try to plot it. I don't know if that plot command works here. Plot T comma F5. Okay. So plot doesn't work here. So क्या करें? So let me copy this into Excel. I think we will have to increase the accuracy, otherwise it will not plot. Data, text to columns, and space next. Finish. Sort. That's what I thought. 1 minute. We need to increase its accuracy. By taking at least 40 points, and I will have to define okay. So how do I do that? Just a second. What is the value that we have taken? ये 0.1 लिया है ना, we will take, instead of taking it as 0.1, let us take it as 10. Are you with me?
Yes, sir.
So what will be the change? Here I will have it as 10. Now let us execute. So now you have something. So let me plot it now. Data, text to columns, space next, finish. So 0. So let us try to plot this. Are you able to see that it is oscillating about non-zero mean? Are you able to
Yes.
see that? So this portion of the graph is not correct. Why that is not correct, that I will tell you in a while. But in nutshell, we can use that integration to find out response of a system to any kind of load for that matter. So let us first rectify that error which was there. So here what I will do is I will put it in 0.05. Now let us execute. Yes. So let us plot control copy, control paste, data text to columns, text to columns, space, finish. This is done. Let me plot this now. Okay. So just give me a second. Unfortunately, this does I can't take this as 100. I will check if I can. 60. Yes, now it's better. Data, text to columns, finish. Set. So are you able to see this? There is a clear indication that it is going to, it is oscillating about somewhere here. So what is it should oscillate about which value? It should oscillate about the static deformation. Do you agree with me?
Yes, sir.
So if I do that, 10 divided by k is the static deformation. So can you tell me how much is 10 divided by
1 into 10 raised to minus 3.
so 1, 2, 3, 4. Sorry. So what is this value? Tell me.
1 into 10 raised to minus 3.
Like this.
Yes.
So see, this oscillation should occur about 0.001. It occurs about 0.001 for some time and later on it drifts. Why it drifts? Because there is a addition of numerical error that we will discuss little later. Are you with me? That can be marginalized by fine tuning the parameters like the step size. Are you with me?
Yes, sir.
So for example, here instead of 100, instead of 60, if I take 100, this result will be better, but it doesn't execute because there is some limitation here of this program. Let us try whether it executes. It has executed. So now if I plot this data, it will be much better. Data, text to columns. Let me plot, insert. So then this is better. The oscillations are occurring about 0.001. Do you agree with me?
Yes, sir.
This accuracy can be increased if I further increase, further decrease the step size here. So when I divide it by 100, from 0 to t of I make 100 parts. When I divide it by 200, I make 200 parts. So you can, I will just show this as the last one and then we will stop. And then in next class, I will once again explain this program so that it fits in your mind. कि क्या करना है. Are you with me?
Yes, sir.
So let us do this and then we will stop. One thing, this is going to be your first assignment. So I will upload your first lab assignment on the Google Classroom where I'm going to change the loading type and you are going to do this program for that loading type. Okay.
Yes, sir.
So it will take some time. I will copy this code meanwhile and I will send it to you. You share it with everyone else.
Yes, sir.
SDOF forced response. This code. So I have sent it to you. So it takes a lot of time for 200. Is Soham there in the class?
Yes, sir. Yes.
Yeah, so you have the star class. Those who have star class, they can leave now. We are done. I am just now demonstrating it with the final resolution. That's all.
Okay, sir. Okay.
Okay, so this is taking too long. So instead of 200, we will start with, we will try with 150. Are you with me?
Yes, sir.
So I will copy this code, reload it. There may be some net problem. I don't know why it is taking. Yes. Now I will paste this, execute this. So it 150 it doesn't take. So probably the largest one will be 120. Execute. Yes, for 120 it has executed. So if I, so this was with 100 parts. Now this is with 150 parts. Data, text to columns. I will plot this. So you can see with 100, see, with 60, this was the accuracy. Accuracy was at toss when it comes to the higher values of time intervals, when the response had to stabilize at 0.001. It is better with with 100 parts, and it is even better with 150 parts. Are you with me?
Yes, sir.
So numerical solutions always have this problem. You have to judiciously choose the time interval. That is but obvious. Okay, so with this, I think we will stop for today. We will meet day after tomorrow for SD class. Chalo, good day.
Okay, sir.